Welcome to the pharmaphorum podcast. This is Deep Dive editor Eloise McLennan, and today I'll be speaking with Mohit Manrao, SVP, Head of US Oncology at AstraZeneca, as well as President of the AstraZeneca Foundation, for a conversation exploring the application of AI in cancer care. Welcome, Mohit.
Thank you, Alice, for having me.
Now, the global impact of digital transformation in the last few decades cannot be understated, and now artificial intelligence, or AI, is making headlines for its potential to transform lives. By applying this rapidly evolving technology in the world of drug discovery, the possibilities can be taken to the next level with one goal in mind: improving patients' lives. Now, before we sink our teeth into this topic further, though, Mike, could you possibly briefly introduce yourself for listeners and describe your journey up until this point in your role at AstraZeneca?
Yeah, as you said in the beginning, I lead the U.S. oncology business for AstraZeneca in my day job, and on the side, I also head our AstraZeneca Foundation. And I'll come back to it how they interconnect. But I've been with AstraZeneca for about 13 years now. Have worked across different continents. Started in Japan, Asia, and then actually moved into Europe. And most recently, for the last 3-4 years, I've been in the U.S. I've done roles in global. That gave me a big picture of different health systems, challenges faced, nuances, and both differences and similarities. And actually, what you see is everywhere we are looking to champion across the ecosystems better health for everyone. And while there are differences in health system, there are many commonalities on how impact can be enhanced. And that's where actually, as I work in my day job of leading the US business, I also know that partnerships are critical, and thus working as the chair, as the president for the AstraZeneca Foundation, I'm able to work with different NGOs at the grassroots level to solve for those disparities that show up across the world, across different regions, and that actually fuels my passion to have impact on cancer patients.
So you've got a lot of experience in a lot of different locations and seen a lot of what has changed within oncology. So when it comes to the possibilities of AI in R&D, can you take us back into our central topic and talk about some of the most promising potential applications of AI in the life sciences setting generally, and then also go into a bit more detail specifically within oncology and AstraZeneca's own endeavors there?
Yeah, sure. If we think about oncology and the entire value chain of having impact on patients, it starts with absolutely looking at understanding biology, then really designing, understanding targets and designing medicines and potential candidate medicines across those, leading into trials and patients who are recruited into the trials, and then ultimately to bringing those innovations as medicines on the bedside and serving them in the clinic. And, if you think about this continuum, AI is an accelerator, a catalyst, an enabler, choose your word. It really can actually unlock the whole potential of where we are. We live in this golden era of oncology, as I call it today, where data, technology, and science are coming together and uncovering opportunities which we couldn't even imagine, a few years back. It's really helping us understand biology, unlock opportunities, and have impact on patients. And then if you think about R&D, I talked about, it helps us search novel targets faster, better. It helps us really look at some of the multimodal data that exists out there in ways that we hadn't combined them and looked at it to uncover new insights that help us understand what are the drivers of the disease, which then help us really target and develop new medicines around it. So that's the opportunity that holds in R&D that's happening today. And we can dive in deeper, but I'll leave it at this point, at this level, and let's see where it takes us.
I would like to dive deeper into two terms that you've mentioned so far. The first being partnerships. Did you want to share some details about the multi-year partnership with Pangaea Data, which is focused on advancing precision healthcare within the multimodal AI? And I just want to touch upon, for those listeners who are wondering, multimodal AI refers to the form of the technology that processes and interprets information originated from multiple data sources, such as text, images, and video. Could you also speak on the work that AstraZeneca is doing with Tempus and Pathos AI in regards to multimodal AI? That would be fantastic. So let's have a talk about the partnerships that AstraZeneca is currently working on.
Yeah, sure. And as I said earlier, like partnerships are key to moving the needle for patients. If you think about what we are doing, we've got a lot of data at AstraZeneca, whether it is the data we have from our trials, from pathology, for ctDNA, clinical data, outcomes data, imaging, multiomics, proteomics, all of that data exists. But also externally, through our partners, we've got equivalent and further enriching data on clinical side, outcomes, again, spatial biology, multiomics, etc. You take all of that data, you have an opportunity from that to do multiple things. For example, with Tempus and Pathos AI, we are combining the power of our data with theirs and the technology to create what we call foundation models that will help us really uncovering the biology of why a disease happens, how it progresses, what are the downstream channels for that, and how we can actually design drugs to block those or really deal with those gaps that exist which lead to those diseases. So that's work we're doing with Tempus and Pathos AI in terms of using the power of those multimodal data that exist out there to create foundational model that will help us accelerate our drug discovery and disease understanding and drug development. On the other side, the other partnership you mentioned with Microsoft and Pangaea is with using similar data sets in a different way, where we're looking at, now that we have those real world data sets that exist, are we able to understand which patients would benefit from what clinical trials using those data, or which patients would benefit from what standard of cares to be able to support physicians drive guideline concurrent care. So again, developing models and algorithms through those multimodal data sets that would help, say, patient X would ideally benefit from these kind of treatments, and here's the two trials that are open for these kind of treatments coming to the market, or they would actually benefit from XYZ standard of care that exists based on their profile, their proteomic, their genomic, their pathology data, etc. So those are the partnerships that help us impact patients in much faster and more broader way.
I want to touch on that part there, because improving access to innovation is clearly crucial. And you mentioned access. Can you go into a bit more detail as to how equity gaps in oncology can be minimized and, if not closed, and how collaboration with patients themselves is beneficial here?
Yeah, it's really critical. So I think one of the things which we all have to embrace, and one which is front and center at AstraZeneca, is equity should not be an afterthought. It should be built in from the word get go, right? So it means when we start looking at understanding of the disease early, we need to have diverse biosamples so that we are not understanding the disease only in a population that is not representative of the populations ultimately we want to serve in. Again, going from there, clinical trials need to ensure we have diverse representations of patient populations in clinical trials so that we know these medicines that we bring to market are effective for all versus just a population studied in the trial. And then on the other side, when we are bringing these medicines and getting them to patients, we want to ensure we understand the barriers that come in the way for different populations to access those medicines, and we are actually eliminating those and setting a level field so that equity is front and center. So it needs to be built in from the word get go and thought through holistically across. And AI is again helping us there in many ways, but also is something that we should keep in mind as we go more and more developing using AI, that the biases don't get built in with samples and other things that are missing the broad representation. And I'll give you a few examples. One of our tools that got published last year, called Milton, it helps actually predict over 1,000 diseases before they even present symptoms, and these diseases include cancer as well, just using routine biomarkers. And this was recognized by World Economic Forum as one of the 6 transformative AI applications in healthcare. Now you take the impact of this tool. Now everybody who has access to routine biomarker testing at their general practitioner or their family physician at their physicals annually, This tool can actually solve for equity gaps by looking at the risks for everybody and help identifying who could actually develop a disease 10 years later. Like, again, examples of AI like this could help unlock opportunities. Similarly, on the other side, if you come to clinical trials, we know here in the United States, African American women are at a much higher risk in breast cancer, but we still struggle to recruit them into clinical trials for cultural barriers, for other barriers that exist in getting them access to trials. Again, working with AI and looking at which centers have this population show up, and working with physicians and local partners there, you can help um, reach them culturally in a relevant way to recruit them into those trials, thus bridging the gap. So again, a combination of AI insights along with local partnerships could help there. So there are a multitude of these examples where access and equity could be solved for or actually supported with use of AI.
I want to turn now to a specific example in lung cancer. According to the World Health Organization statistics, lung cancer is the leading cause of cancer related deaths globally, with 2.5 million new cases and approximately 1.8 million deaths annually. If we look at the geographics, in Thailand, lung cancer is the second leading cause of death, accounting for 17,220 new cases each year, which averages at roughly 40 deaths per day. In March last year at ELCC in Paris, AstraZeneca presented new data from the CREATE study. This research highlighting the use of the, let me get this right, QXR LNMS tool developed by Cure AI to demonstrate the effectiveness of AI-driven lung cancer screening through chest X-ray images. Now, can you tell us a little bit more about this innovative tool and the data, as well as the industry's general shift towards utilizing AI for companion diagnostics in this respect?
Yeah, so let me take it in two parts. So let's start with the specific example you talked about in lung cancer. Lung cancer has really dismal outcomes, and one of the reason it has dismal outcomes is it is detected at a metastatic stage when the cancer is already spread outside the lung and becomes very difficult to treat, and the 5-year survival rates are less than 1 in 5 surviving at year 5. From that perspective, one of the biggest opportunities, while of course bringing innovative therapies is one, is to actually I help people get diagnosed much earlier when the cancer is in stage 1 or 2 and is resectable or treatable and is not that aggressive. We have seen, for example, lung cancer screening can actually help people and reduce mortality and identify patients early. The challenge is lung cancer screening uptake is low because of many reasons. One of the reasons is also infrastructure for some of the countries, like you mentioned. They do not have enough CT scanning machines or enough resources to put behind that. Now, here is a great example of AI technology coming together and science coming together, but also equity at the core of it. For example, imagining those countries where CT infrastructure doesn't exist, but an X-ray is available, which in the past nobody could use. With naked eye could read a X-ray and say it's a cancer, but using AI algorithms which are trained, you can now say there's a likelihood of cancer in this patient, or actually a higher percentage. You can say there's no cancer. Negative predictive value, which we call, was in this trial you mentioned, was around 90+%. So that means you could actually say this individual's X-ray suggests there's no cancer, whereas this individual's X-rays could suggest and needs a follow-up. Thereby, you could actually enrich the people who need to go through the process of a constrained resource environment. So this is the Cure AI tool, which was using X-rays and AI technology to actually leapfrog where infrastructures were a gap and identify patients whom we needed follow up. And this has been done in 20 plus countries and actually has shown such a big impact in terms of individuals. Now 50,000 plus individuals identified who could be at risk of lung cancer. And the difference between being identified at stage 1 versus stage 4 is actually your survival could be 80% plus versus less than 20% if you are stage 4. So that's one great example and that you talked about. The second thing you asked about is in terms of diagnostics, how this technology is transforming oncology space. Oncology in the last decade has seen precision medicine come to life, where we are able to actually understand the biomarker of an individual's disease that is actually leading to the cancer growth. Once you identify the biomarker, you match a medicine to it, you have a much more effective medicine with less side effects that helps control cancer, or in some cases, actually cure or eradicate cancer completely. Now, to identify that biomarker, AI is giving us really, AI is acting as a catalyst, both in terms of research that we are now understanding what are the drivers of the disease, but also in terms of when we bring the medicines to market to be able to quickly understand through computational programs what the biomarker is and which medicines would be effective. We recently or last year, we presented data of one of such computational biology related biomarker. It's called it's a TROP2 biomarker, and the data showed it by identifying patients who had that QCS component biomarker identified through that had a better response to a specific therapy. Now that FDA just gave us, a breakthrough designation for that kind of a biomarker. When that comes to market, what it means is using technology, you're identifying individuals who are best suitable for a specific treatment to get a better outcome. And that actually is a evolving space and is rapidly transforming outcomes for patients, and actually is also in a way solving for equity gaps, is also in a way solving for health system sustainability and challenges by really ensuring right people are getting the right medicines that impact their cancers.
Thank you. It's all very fascinating and very full of hope. I want to just quickly touch upon the way that you speak about AI in terms of diagnostics and in terms of data. It's very much, you mentioned the word catalyst, almost a starting point. And I want to ask you a little bit about the importance of maintaining the human touch, the human in the loop, which is so spoken of when we talk about AI. Can you talk about how important that is in terms of R&D and the care setting?
Oh, it's a great point. I mean, and this is why I refer to AI as a catalyst, as an accelerator, because the work humans do today is really meaningful and impactful in this space and cannot be imagined without them, right? Having said that, like many other tools that has helped us move our understanding of biology, our speed to develop medicines, our ability to be bringing precise treatments, and our ability to deliver those and remove access barriers, AI is an enabler, a catalyst for all the same, and the human centric approach is critical. I would also say this technology, when used appropriately, can help humans free up time to really do what they do best, is connect and use that power to move people and have impact. And there are so many of such examples. Here at AstraZeneca last year itself, 12,000 of our employees have been through our internal training on how AI can help them be more efficient and effective and actually free up their time for them to use for higher order things that would, again, move the needle for patients. If you look at externally, AI today, with all the tools that are out there in oncology practice with ambient hearing, are freeing up time for physicians who otherwise after a call have to record their notes and put in all the and administrative work. By freeing up that time, it's giving them more time to spend with patients and do the human things with them from that perspective. So again, we need to ensure, like you said, human is always in the loop on decision making, on using these technologies, and actually now you through this freeing up time for doing things that humans can do, which AI can never replace.
And finally, taking everything we've discussed so far into consideration, where do you see these developments, these enablers, as you said, leading to in oncology within the next 5 years?
Yeah, as you heard me say throughout this, I am very optimistic, hopeful, like many of our patients are, on the next innovation, helping them go for the next milestone that they may be looking forward to in their cancer journey, to spend more time with their young kids, or celebrate another birthday, etc., etc. I'm very hopeful that where we are today in the next 5 years, with the pace of innovation that's happening in oncology, with the golden era we are living in, with AI becoming an enabler, we will see progress happen faster. Here at AstraZeneca, we many times talk about our mission and vision of one day eliminating cancer as a cause of death. This era we are living in is absolutely helping us imagine that, and AI and the technology that's coming along is helping us accelerate that. So I'm very hopeful that all these things, when we put together, is going to help us solve for cancer and hopefully eliminate this as a cause of death in the coming decade.
Fantastic. Well, thank you, Mohit, for joining me. I look forward to seeing what AstraZeneca does this year.
Thank you so much for having me, and I look forward to how we all can be a part of a solution the society needs.
And that concludes another episode of the pharmaphorum podcast. You can find more information about this episode, including a download link and information about previous installments at pharmaphorum.com/podcasts. The pharmaphorum podcast is also available on Apple Podcasts, Spotify, Overcast, Pocket Casts, Podbean, and pretty much wherever else you download your other podcasts from. Just search for pharmaphorum and follow and hit subscribe. Of course, don't forget to visit our website itself, where you can sign up for daily and weekly news and analysis bulletins. And do follow us on Blue Sky and LinkedIn at pharmaphorum. That's all for now. Thank you for listening.